Up in lesson 5.3, and we are ready to talk about example D. Okay. As we look at example D, k of x equals 2 times the cube root of x minus 1 minus 3. Thoughts here?
We're going to go down. Doing the cube root graph.
Okay. So I heard two things there. One, I heard that we are going to be moving down 3. And then when we start talking about our XY chart, we have to recognize that this is a
Cube root
graph, right?
Cube root.
So pay attention to that.
Right.
What else you got?
Move to the right. Factor 2.
Okay. This 2 out front, when it's a number multiplying out front, it is a vertical something or other. In this case, 2 is bigger than 1. So it is a vertical stretch. So we're going to practice how to do the vertical stretch again. And what else? This minus 1 under the radical is a right one. Okay. So with that in mind, my recommendation is that we grab our cube root chart of values. Okay? Because this is a cube root. So when I grab my cube root of values from the front side, we had what? -8, -2, -1, -1, 0, 0, 1, 1, 8, 2. Does that sound right?
Yeah.
Okay.
Yeah.
And then the right and down are just easy movements on the graph. How do I vertically stretch by a factor of 2?
You go up here. Or
Well,
you go right 2.
No. How do I vertically stretch by a factor of 2? Okay, we're going to multiply by 2, specifically because it's a vertical stretch. We're multiplying the y values by 2.
Yes.
Only the y values. Okay, so I like to do this. I like to extend my chart, so we have the visuals to look at. So this last column is going to be whatever 2y is. -2 times -2 is -4, -1 times 2, -2, 0 times 2, 0, 1 times 2, 2, and 2 times 2, 4. So now the idea is my vertical stretch is going to be represented by the original x values that did not change and my new y values. So teacher recommendation here is to graph that set of ordered pairs. And then after you graph that set of ordered pairs, I'm going to tell you to move them, right? So we're going to graph. And then we're going to move one right, 3 down. Okay. So let's see. Instead of -8, -2, I'm at -8, -4. Instead of -1, -1, -1, -2. Still 0, 0. Instead of 1, 1, it's at 1, 2. Instead of 8, 2, it's 8, 4. Realize this is a stretched out version of the original cube root graph, right?
Yes.
Okay. Each of those y values doubled its distance from the x-axis.
Right.
Take each of those points and move them. According to my original equation, right 1, down 3. So, right 1, down 3. 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 And then you're connecting your new points. looking something like that. This one we only multiplied it by 2 because there was just a stretch, no reflection like yesterday. So it stayed facing the same direction. Domain. What are your thoughts on domain?
Negative infinity, positive infinity.
Yeah. It goes infinitely left. It goes infinitely right. So the domain of the cubics is always going to be negative infinity to positive infinity. What about the range of this cubic? Same thing. It goes infinitely up and infinitely down, so negative infinity to positive infinity. Okay. As I said yesterday in homework, it'll be more about being able to identify the right graph via multiple choice in homework. But when you see my review worksheet tomorrow, I'm going to have you graph, we need to get to knowing how to graph them by hand. Okay, so the same process here is what you'll see me go through. Okay, questions there? Okay. Ready to look at the next section then?
Yeah.
Okay. As you look at these next sections, or this next section, as you look underneath the radical, the big difference from what we were seeing in the previous section is that these numbers under the radical, the x's have a coefficient, right? So instead of it just being x plus or minus a number, so we just know we're moving left to right, there's a coefficient, okay? Yeah, we could talk horizontal stretch or something, but that would be a lot harder to graph, okay? The easier way to graph this is we're going to rewrite these functions to make them easier to use the transformations, and then we're going to describe that graph. So describe what the transformations are. What do you notice under our radical here on example A?
Perfect squares.
Perfect squares? What do these two pieces have in common?
Divisible by 4.
They're both divisible by 4, yes? So while the 16 happens to be a perfect square, I wouldn't count on that always happening. But what I'm looking for here is there's a GCF. So under my radical, I'm going to suggest that we factor. So 4x plus 16, there's a GCF of 4. If I factor that GCF under the radical, that leaves in the parentheses x plus 4, right? And then there's still a plus 7. Now, what's important here is that my GCF was a perfect square. When you have something multiplied together, you can take the square root of just that multiplied part and pull it out front. So what is the square root of 4?
2.
2. So we're going to put a 2 out front of the radical. So this is going to be 2 times the square root of x plus 4, and then still having a plus 7. Now, I'm realizing there's not going to be very much room here, but okay. So when it says rewrite the function to make it easy to graph, this is your rewrite here. Because I can look at that, name 3 quick, easy transformations, and know exactly how to graph this. Much easier than the other one. Okay, so what are the transformations you're going to name here?
You're going to vertically stretch by a factor of 2.
Okay, vertically stretch by a factor of 2. What else?
So left forward,
Up
7.
Up 7.
Okay, we're going to translate left 4 because it's a plus 4 under the radical. We're going to translate up 7 because it's a plus 7 at the end. Yes? And what graph is this being done to? What is my main
Square
base
root.
graph here?
Square root.
Square root of x, yes? Okay,
Wow.
those are the things that would be ideal to be mentioned when it says describe the graph. those are the pieces that I'm going to mention. So I'm going to say the graph of y equals square root of x is vertically stretched by a factor of 2. Vertically stretched by a factor of 2. And don't just tell me left 4, up 7. Use a good verb there. Translated, shifted, moved is okay. You know, give me a verb. Don't just tell me 4 left. That drives me crazy. So, translated, 4 left, and 7 up. Okay? Somehow or another, get all those pieces in there. That's what I'm looking for. Okay, B. If we're ready. I think we're about ready. What things do you notice on B?
Perfect square.
Okay. Is there a perfect square there?
Yeah.
And this time it is just 9 times x. We don't have to worry about factoring out GCF because there's just one term. So what do you know about the square root of 9?
It's 3.
3. So I can rewrite this to be, the negative's going to stay out front. Whoops, wrong page.
Oh.
Okay, negative's going to stay out front. Square root of 9 becomes 3, and then square root of x stays under the radical. So this one, the rewrite is a little bit simpler because you're just pulling the square root of 9 out, putting it as a 3 out front. Okay, what are the pieces we're doing? What are my transformations is what I should say there. Okay. Reflection across the x-axis because of the negative. The 3 tells me to vertically stretch it. And what graph is this being done to? Square root of x is my base graph again. So I'm going to write this similar to last time. The graph of y equals square root of x is, and when it comes to the stretch and the reflection, it doesn't really matter which you put first. Okay, so let's see, I'm going to go ahead and say vertically stretched by a factor of 3 and reflected across the x-axis. Okay. One more. C is the cube root of negative 27x plus 81. Thoughts? Why would I want to talk about 9 here? What are we overlooking if we talk about 9? I would talk about 9 if this is a square root. But what did we forget?
Cube root.
It's a cube root. So do I care about 9?
No.
I don't care about 9 because it's not on my cube root list, is it?
No.
Okay. So I like the idea of noticing there's something that they're both divisible by, But let's pick a cube root they're both divisible by. 3 technically is not the cube root they're divisible by.
27.
20, or I guess 3 is the cube root. The perfect cube, that's what I need to be saying, is 27 here, yes? Now, here's the slight catch. What do you notice about 27x? It's a negative. So I'm going to suggest when we factor this out, we factor out a negative 27 under the radical. It's going to change things up a little bit. So I'm going to have the cube root. When I factor, I'm going to do this in 2 steps, the negative 27 out. Negative 27x divided by negative 27 is going to be x. Plus 81 divided by negative 27 is going to be minus, is it 3? 3. Now, again, I have this negative 27 out front. What is the cube root of negative 27?
Yeah.
Negative 3, yes? Because you can do cubes of negatives. So I'm going to rewrite this. Cube root of negative 27 is negative 3, so I'm going to put negative 3 out front, and then times the cube root of x minus 3. And if you like the number 3, this is the problem for you, isn't it? Didn't realize till I made my answer key up how many 3s I had in this problem, so. Okay. What graph am I altering? This time when I mention my graph, I'm going to say it's the cube root of x. I see 3 transformations. What all is being done? Okay, the negative out front is going to reflect it across the x-axis. What?
Right 3.
Okay, the minus 3 under the radical is going to take me right 3. What about the 3 out front? That is our vertical stretch. Okay, so I'm going to write that all out. I'm going to mention my stretch and reflection first, and then the right 3 at the end. So I'm going to say the graph of y equals cube root of x is vertically stretched by a factor of 3. Reflected across the x-axis. And translated right 3. Okay, make sure you have all the pieces there. Looks like a decent amount of you were already ahead of me, so that's good. When we get to the bottom section next, we're going to go backwards. On the front page, or at the top of this page and the bottom of the front, we're graphing. They give us the equation, we draw the graph. Now, they're giving us the graph, we just have to write the equation. So, still being able to identify all those transformations, which type of graph it is, putting it all together. So let's look at this bottom section. And then depending on how well you see this bottom section could be easy or difficult. So, okay. As you look at A, what types of things do you notice? Which graph is it and what's done to it? It's a which graph? Okay, so when I write my equation here in a moment, it's going to be a square root of x graph, right? Because square root of x is the one that's half a parabola. Where's it moved? Or maybe I should ask, where does it normally start?
It's It's moved to 1 to 1.
Yeah, it normally starts at 0, 0, and now it's moved right 1, up 1. So when we write our equation, we have to make it right 1, up 1. Now, pretty obvious there's no reflection. The tricky one to watch out for is the stretch or compression. Okay? Think about what your basic square root graph looks like. Yeah, it starts at the first point, yes. And the next point from there is over 1, up 1. Is my next point from 1, 1, is the next point over 1, up 1?
No.
Well,
Yes.
you're looking at that labeled point. But would it go through a point that is over 1, up 1?
Yeah.
It would. And then if you look here, from 1, 1 to 5, 3, that is over 4, up 2. Does that match with one of the points in my XY chart? If you think about the XY chart, it was 0, 0. From 0, 0, you go over 1, up 1, which there wasn't a point there, but it looks right. And then also you go over 4, up 2, which that is the point 5, 3 that's matching. So is there any vertical stretch here?
No.
No, because these points all match up. So, can you write your equation? Unless it specifies, I think I just used y. I guess it says what radical function, so maybe we should use f of x. It doesn't matter to me. But there's your start. Y equals, no stretch, no reflection, so go straight into your square root. Square root of what? How do I show right 1? X minus 1. How do I show up 1? A plus 1 outside. There you go. That's your equation you're looking for there. You're just trying to identify all the pieces. Questions? Okay, let's try example B. What graph is this? This is a cube root of x, isn't it? It's not just half a parabola, it's the whole curve. How far did it move?
Up 3, left 2.
Okay, yeah. Normally the centerpiece is at 0, 0. This time the centerpiece is at negative 2, 3. So that is moving left 2 and up 3 is my centering piece. Any reflection? No, it matches up with the same graph that we have on the front. Okay. What about a stretch? If you go back and think about our original curve has the center at 0, 0, yes? And what are the first set of points from that 0, 0? 1, 1. Does that work here?
Yeah.
Yeah, because to go from negative 2, 3 to negative 1, 4, it's over 1, up 1. We could also go over 1, down 1, and land on a spot, couldn't we? So with that in mind, there's no stretch again. But I'm prepping this for a reason, right? There will be stretches eventually. So this is what, we can look at. So write an equation. Y equals the what?
Cube root of x.
Cube root of x.
Or minus 2. Plus 2 should be plus 2 because it's the opposite, right?
Okay, so officially it'll be plus 2 since we're going left 2. And then up 3, plus 3. If we're left to right, use the opposite sign.
Awesome.
Okay. Move along. I will warn you on C. Beware. I notice this happening in homework, and when I'm working to put this worksheet and quiz together, they keep doing this to us. Always pay attention to how are my graphs counting. Is there something weird going on here? I mean, going up, it's 0, 1, 2, 3, 4. But what do you notice going right?
2 kills 2.
Yeah, it's counting by 2s, isn't it? Just beware, because it just makes it a little bit more difficult to process. So, okay, what type of graph is this? This is the square root of x. Okay, where does my endpoint move to? Normally it'd be at 0, 0, but now it went where? Yeah, -5, -4, so that means it went left and down. So it went left 5, down 4. Any reflection? No?
No.
Ask though, because I do believe I saw it happening in homework. Now, stretch.
Yep.
This is a tough one to process through for me. And only because of the counting weirdness. Okay? If you go by the points they have marked, -5, -4 to -1, -2. That is a difference of going where? From -5, -1, you're going over 4. And from -4, -2, you're going up 2. Is going over 4 up 2 part of a normal square root graph?
Yeah.
And it is. Okay? I struggle to use, because really going over 1, going, what is it? Over 1 would just be going here. There would be over 1 up 1. It just doesn't look like it. But over 4 up 2, it does land. And I'm guessing this is one if you went over 9 up 3. Okay, which are all values that should sound familiar. So again, no stretch, but we checked. Okay, did you write it? Y equals square root of, to do left 5, we say plus 5, but to do down 4, we say minus 4. I see some of you flipping back. You've got that chart on the front page again, don't you? Okay, 2 more. I can be as quick or as slow as you want to take these, I guess.
Well,
Okay, D.
cube.
Okay, we've got a cube root graph. Why did I write cube root of 3? Try that again. Okay, we got a cube root graph. What else? Ooh, vertical stretch this time? And here's the deal. The center's at 0, 0, isn't it? So did it move left or right? Did it move up or down? Did it reflect? No, the only thing we've got to check here is your stretch. And guess what, guys? From 0, 0, it doesn't go over 1 up 1, does it? It goes where? Over 1 up 2. So that is instead of going over 1 up 1, we went up 2. So that 1 got multiplied by 2. And so this is going to be a stretch. And it is going to be a stretch by a factor of 2. And the reason is because it was supposed to be 1, but it was a 2. And 1 times 2 is 2. If that makes any sense there. So what's the equation we write?
Y equals cube by 2.
2 times the
Cube root of x.
cube root of x. And one more. One more which there's not points, so you just have to put your own points on. Let's see, what graph is it?
Square root.
We're talking square root. Did it move?
No. Right one.
Yeah. It's supposed to start at 0, 0. Looks like it's starting at 1, 0, so it did move. Right 1. Doesn't look like it moved up or down. Reflected?
No.
No, it's still going the correct way. Stretch.
Yes. 2.
Yeah. Normally it's supposed to, from the vertex, go over 1, up 1, but it goes over 1, up 2. And when it goes over 1 up 2, that is the same idea of that 1 got multiplied by 2, so this is a stretch again by a factor of 2. So write your equation. Y equals stretch of 2 goes out front times the square root of x minus 1 for right one. Okay, guys, you've got a little bit of homework time. I would encourage you to use it. It's lesson 5.3 in Savas.